All right, good morning, Honors Edward 2. I'm going to show you a couple of things real quick today before we get into our actual notes over solving by graphing. First thing I want to show you is how to graph piecewise functions, and I'm going to show you that a couple of different ways. So to do this, we're going to use this example, which is coming straight from your homework, which is assigned on Wednesday, due on Monday. Just as a reminder, guys, you do have two homework assignments due on Monday, one of which was assigned on Wednesday, the other is being assigned with the sub today. We're going to take a look at this example where we've got this piecewise defined function, 2x plus 1 where x is less than or equal to 1, negative x plus 2 where x is between negative 1 and 2, and negative 3 where x is greater than or equal to 2. So the first thing I'm going to show you how to graph it piecewise is going to be using Desmos. So when you graph a piecewise defined function using Desmos, notice that Desmos is kind of lackadaisical. It doesn't even need the y equals over here. And then the only way that you have to worry about restricting your domain or putting those kind of inequalities in there is you use those squiggle brackets that we've been using for domain and range for a set of values in Unit 1. Once you type that in, it'll graph it all for you. The only thing to notice is it will not put open and closed circles for you. So it's kind of up to you to understand that where x is less than or equal to negative 1, in other words, this piece right here, this would be a filled in dot. For both of these endpoints, since it's x is strictly greater than negative 1 and less than 2, those would be both open, and then this one down here would be a filled in dot. Understanding that, then you've got a couple options to pick from. It looks like you've either got this first option or this last option, which means that you really just have to look at your domain and range. For domain, notice you're going out to negative infinity. You're also going up to positive infinity. And then as far as the range is a little trickier. Notice that you start at negative infinity, going up to, it looks like, negative 1, so where y is less than or equal to negative 1. And then you also have the second interval between 0 and 3. And so there's your answer. That this should be your correct answer. Now, Desmos is great, and it's a good thing to use while you're working on homework because you can see how easy it is to type in those. If you're wondering where the less than or equal to signs are and where some of those extra signs are, just click on this keyboard down in the bottom left corner and it will have kind of some of those extra options here for you. Now, downside of Desmos, you don't get to use it on a test or a quiz. So, let's look at how it is that you would use a graphing calculator to do it. I've already got the first one typed in here with 2x plus 1, and our interval is x is less than or equal to negative 1. And notice how I've had to type those in. You've got to use parentheses, a division sign, and then put your interval. So when you graph it, here's what that first piece looks like. Now here's the other downside to graphing on a graphing calculator. When you get to that second interval, where it's supposed to be where negative 1 is less than x is less than 2, unfortunately your graphing calculator cannot do both of those. So we're going to have to type that in as x is greater than negative 1 and x is less than 2. So let's go ahead and do that. Again, I'm going to use parentheses, negative x plus 2, divided by, and then I'm going to have to use a couple sets of parentheses here. For the first one, we're going to say that x is greater than negative 1. So I'm reading that a little backwards. X, and then to get the greater than sign, hit second math. Second math will give you kind of all these different signs. For this one, we're going to use option 3. So x is greater than negative 1. Close my parentheses. And then to say and, because we're going to have to say x is greater than negative 1, and also x is less than 2 here. And is in the same menu. So you hit second math, just arrow over to logic, and is your first option. So and then now we're going to put in our second set of parentheses, x is less than 2. So second math again to get less than, option number 5, x is less than 2. Then close out both of those sets of parentheses. When you hit graph, there's your second piece for you. Third piece here is a little bit easier. We're going to put in our function first, which is just a constant value of negative 3, and then put in our restrictions, so where x is greater than or equal to 2. Again, that's right here for you. So negative 3, where x is greater than or equal to 2. 4 there. Close our parentheses, hit graph, and here's our piecewise defined function. So notice it looks the same. Again, just like on Desmos, it's not going to show you those open and closed points, so it's up to you to understand where those are at, but then you can also use that to help you answer questions on the homework. And also the advantage is you also get to use it on the test. Alright guys, so this graphing piecewise defined functions, hopefully you got something out of that. Hopefully that'll help with getting your homework done. And make sure you watch the second video over graphing and solving by graphing. Alright, I'll see you Monday.